So we're going to start this one by subtracting 2048x from both sides of the equation because we want to be able to factor this and we need it set equal to 0 first. So that's our first step. And once we do that, we're going to factor this as completely as we can. And that's probably where you're having a little bit of difficulty. The first thing, we notice that they both have a factor of 4 and an x. And if we factor that out, we get x cubed minus 512. Now what you might not have noticed or recognized is that x cubed minus 512, that is the difference of two cubes. Now if you're not sure, you can test the second number, which I did, and played around with your calculator, because if it's not the difference of two cubes, we're probably not going to be able to factor that. So I looked and found that 512 is actually 8 cubed. So I'm going to rewrite it just like this, just for a minute, because I looked up the formula. It's on page 80 in your textbook, and I'm going to pull that in so that you can see how this factors. So here's our formula. Factor this, and since we have x cubed minus 8 cubed, x is our a and 8 is our b, so we'll just replace those in here and we'll have it factored. So we'll have x squared plus 8x, because we multiply a and b, the 8 and the x, plus b squared, which is 8 squared, or 64. So that's how this one's going to factor. Now it's easy enough to set each of these first two factors equal to 0 and solve for x. So I'll go ahead and do that. But this last one, we're going to have to use our quadratic formula because it doesn't factor any further. And, well, I guess you could complete the square for it if you like. But I'm going to show you with the quadratic formula. So if we do this, solve this equation, we have x is equal to 4, and on this one x is equal to 8. So there are two of our answers. So this last one, we're going to use our quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. In our case, b is 8, so negative 8 plus or minus the square root of 8 squared, which is 64, minus 4 times a, which is 1, times c, which is 64. And then we're going to divide it all by 2 times 1. And as you can see, we've got 64 that we're going to subtract from it 4 times 64. So we're going to have a negative underneath our radical. So we're going to get an imaginary number, which is why they tell you up here they want it, your answer in the form a plus bi. So now we have negative 8 plus or minus. That's going to give us the square root of negative 192, because that's 64 minus 256. And we're dividing that by 2. So if I rewrite this, I'm going to have a negative 8. I'm going to separate it already, since I'm going to have to separate it anyway. Negative 8 over 2. I have plus or minus. And if I rewrite that with an I can do I square root of 192 over 2. Now I want to see if I can clean that up a little bit. The first part is easy. Negative 8 divided by 2 is just negative 4. Then I have plus or minus. This square root of 192, we've got I times the square root of 192. I want to see if there's a perfect square that's a factor of 192. And playing around with the numbers again, I found that 64 times 3 will give me square root, that'll give me 192. So I'm going to rewrite that as I times square root of 64 times the square root of 3 divided by 2. Now the square root of 64, I know what that is. That is 8, so I'm going to rewrite that as just a plain old 8. And so I have 8i in square root of 3. Now, since I'm dividing by 2, 2 will go into 8 4 times. So what I actually end up with is negative 4 plus or minus 4 square roots of 3. And you would have to write that separately as negative 4 plus 4 square roots of 3, and then the negative 4 minus 4 square roots of 3. So there are all 4 of your answers. And since this was actually the 4th, and none of our factors repeated, we should have 4 answers for that one.